Hi, Assalamualaikum. I'm Nurhuda binti Alias. I'm your physics lecturer that will give you a lecture on topic 5 for physics semester 1 SP015. What is topic 5? As you can see on the slide, the picture shows that the satellite orbiting around the Earth. Satellite orbiting around the Earth. And the second picture is a Ferris wheel. And the third one is a race car move on a curved corner of a track. Then the fourth picture is a roller coaster. And then this one is the, what you call this, is a swinging chair merry-go-round that is present in most amusement park. And sometimes we also has gravitron or rotor, which is a big cylinder when you get on and leans against the wall and it starts to spin. When it's spinning quickly, the floor will drop away, but you don't fall because you are pinned to the wall by some mysterious force. And all the situations in the picture are something related with the motion in a circle, that we call it as a circular motion. So topic 5 is circular motion. So we're going to learn more about this topic. But before that, let's take a look to the overview of this topic. What we will learn in this topic. So in circular motion, we will learn three subtopics, which is the first one is the parameter in circular motion. Second one is the uniform circular motion, and the last one is the centripetal force. Under parameter in a circular motion, we will learn the definition of the angular displacement given by theta equal to s over r, period, frequency, which is given by f equal to 1 over t, or t equal to 1 over f, and angular velocity given by omega equal to 2 pi over t equal to 2 pi f. And for uniform circular motion, we will need to describe what is uniform circular motion. Describe what is uniform circular motion. So, and the related equation, v equal to 2 pi r over t, v equal to 2 pi r f, v equal to r omega. We will also learn the conversion unit related to this circular motion, which is 1 revolution equal to pi radian equal to 260 degree. And the last subtopic is centripetal force. In this subtopic, we need to explain what is the centripetal acceleration given by equation AC equal to v square over r equal to r omega square equal to v omega. And also, what is centripetal force? We need to explain what is centripetal acceleration and what is centripetal force given by equation Fc equal to mv square over r equal to mr omega equal to mv omega. Before we go through further, let's look at the learning outcome of or objective of the subtopic 5.1. At the end of this topic, students should be able to define and use what is angular displacement, theta, period, t, frequency, f, and angular velocity, omega. Okay, for topic 5.1, subtopic 5.1, parameter in circular motion. What is angular displacement? Angular displacement is defined as an angle through which a point or line has been rotated in specified direction about a specified axis, and the SI unit is radian. From figure 5.1, we can see that a red dot point through a line has been rotated in a specified direction, which is here is as anti-clockwise. Okay, anti-clockwise, and it makes a arc length S, and the angle theta made by the motion is a angular displacement. So from figure 5.1, we get angle theta equal to S over R, or S equal to R theta, where the angle theta as angle theta, angle theta here is angular displacement. S is the arc length and R is the radius of the circular path. Okay, what is period? Period is time taken for one complete revolution or cycle of rotation, and unit for period is second. For example, to complete one cycle, the time we need is 1 period. And frequency is a number of revolution completed in 1 second, and the unit is hertz or second negative 1. And the equation is F equal to 1 over T. So that for period we can write it as T equal to 1 over F. For an object makes one complete circular motion, the distance traveled are equal to the circumference of the circle, and the time taken equal to 1 period T. This means that for one circumference, the S equal to 2 pi R, the displacement, and the period and the time is equal to 1 period. Alright, the fourth parameter is velocity. The symbol is omega. So what is angular velocity? Angular velocity defined as the rate of change of angular displacement. And the equation is given by omega equal to delta theta divided by delta t, where the theta is theta 2 minus theta 1 divided by t2 minus t1. Theta 2 is final angular displacement, and theta 1 is the initial angular displacement, and delta t is time interval. Angular velocity is a vector quantity, means that it has a magnitude and direction. Unit for the angular velocity or angular frequency is radian per second. Remember, angular velocity also known as angular frequency. And other unit we can use other unit is revolution per minute, rev per min -1, or RPM. Now let's move to the second subtopic, uniform circular motion. So let's look at the linear outcome first. At the end of this topic, students should be able to describe uniform circular motion and convert unit between degrees, radian, and revolution or rotation. Alright, what is uniform circular motion? Uniform circular motion is a motion in a circle at a constant speed. Uniform means constant speed. Now look at 5.2.1, linear tangential velocity v. Linear tangential velocity v is directed tangentially to the circular path. Directed tangentially to the circular path and always perpendicular to the radius of the circular path. In uniform circular motion, the magnitude of the linear velocity or speed of an object is constant and its direction is continually changing, causes the change in velocity. Unit for linear tangential velocity is meter per second. Now look at figure 5.2. So we have a 3 point here. As you can see, the radius for the first point is perpendicular to the velocity. And the second point also, velocity is perpendicular to the radius. And the third one also, velocity perpendicular to the radius. Okay, the speed is constant, but the direction is changes. The speed means that's the magnitude of the velocity. Magnitude, the symbol for magnitude is like this. For example, as here is 25 meter per second, and here also at 25 ms negative 1. Here is also 25 ms negative, ms negative 1. But the direction is changing. Means that the velocity is changes with time, but the speed is constant. Means that the speed is the magnitude of the velocity. The value of the velocity is constant with the 25 meter per second around the circles. For an object makes one complex circular motion, distance traveled is equal to circumference of the circle, or equal to 2 pi r. And the time taken is 1 period t. Like this. Like this. For one object to complete one circular motion, displacement is given by 2 pi r, the arc of the circle, and time taken to complete one cycle is equal to period. And we know that the speed of the v is given by v to distance traveled divided by time, which is equal to s divided by t, that is v. So that we get v equal to 2 pi r divided by period t. Or we can write it as 2 pi rf, because we know that frequency also equal to 1 over t. Okay, and if omega equal to 2 pi over t, so omega equal to 2 pi f. Therefore, we get v equal to r omega, where omega is the angular velocity, and r is the radius of the circular path. It's come from here lah. Come from here. V equal to 2 pi f times r. 2 pi f is the omega, so that we get r omega for v. And also here v equal to 2 pi r over t, we get v equal to 2 pi over t times r, so that we get omega r, which is equal to r omega. Alright. Okay. 5.2.2 unit conversion. So other unit for angular displacement theta is degree and revolution or rotation, with the conversion factor of 1 revolution equal to 2 pi radian or equal to 360 degree. 1 revolution equal to 2 pi radian or 360 degree, which is related to this circle. One revolution equal to 2 pi radian, pi and equal to 360 degree. Now let's take a look to the third subtopic or the last subtopic, centripetal force. 5.3 centripetal force. At the end of this topic, students should be able to explain centripetal acceleration and centripetal force, which is given by AC v square over r equal to r omega square equal to v omega. And the centripetal force is given by Fc mv square over r equal to mr omega square equal to mv omega. And B, student should be able to solve problem. Related to the first one is the uniform scalar motion. The first cases we have a few cases here: horizontal scalar motion, vertical scalar motion, conical pendulum. Exclude bank curve. 5.3 centripetal force. For this subtopic, we're going to learn more about centripetal acceleration, AC, and centripetal force. Now look at 5.3.1 centripetal acceleration or radial acceleration. The symbol is AC or AR. What is centripetal acceleration? Centripetal acceleration is an acceleration of an object moving in a circular path whose direction is toward the center of the circular path and whose magnitude is equal to the square of the speed divided by the radius. Given by equation AC equal to V square over R or AC equal to R omega square equal to V omega, where AC is the centripetal acceleration, V is the linear velocity or tangential velocity, R is the radius of the circular path, and omega is the angular velocity or angular frequency. The direction of the centripetal acceleration is always directed toward the center of the circle and perpendicular to the linear tangential velocity, as shown in figure 5.3. So, as you can see here, the direction of the V is perpendicular to the R and tangent to the circle V. The direction of V is perpendicular to the radius and tangent to the circle. And we can see here, the next figure 5.3, the direction of centripetal acceleration always toward the center of the circle, which is always perpendicular to the linear tangential velocity. Direction of the AC always perpendicular to the linear velocity or tangential velocity. For uniform circular motion, the magnitude of the centripetal acceleration always constant. Uniform circular motion, the magnitude of the centripetal acceleration always constant, but its direction continually changes as the object moves around the circular path. Now we move to 5.3.2 centripetal force Fc. Centripetal force Fc is a net force acting on a body, causing it to move in a circular path of magnitude, which is given by the equation Fc equal to mv square over r equal to mr omega square equal to mv omega, where Fc is the centripetal force, v is the linear tangential velocity, r is the radius of the circular path, omega is the angular velocity, also known as angular frequency, and m is the mass of a body. And direction, and is always directed toward the center of the circular path, same as centripetal acceleration. Okay, like this. From the figure 5.4, we can see that the direction of the centripetal force here are same as centripetal acceleration or radial acceleration, which is both are perpendicular to the velocity, to the linear velocity v. If the centripetal force suddenly stops to act on a body in a circular motion, the body flies off in a straight line with a constant tangential velocity. As you can see in figure 5.5, the direction of the velocity are straight line if the centripetal force stops. Okay. In uniform circular motion, the net force on the system is called as a centripetal force, and the work done by the centripetal force is zero, but the kinetic energy is not zero and given by equation k equal to half mv square equal to half mr square omega square. We have a few cases related to this uniform circular motion that you need to study and understand and know how to solve problems related to this centripetal force. For example, we have motion on a horizontal circle, motion around a curve on a flat unbanked track for car, motorcycle, bicycle, and others, motion in a vertical circle, and conical pendulum. And for this example, we're going to learn in detail during tutorial session. That's all for today. Thank you for watching. Hope you enjoyed the lesson today. And the next topic, we will learn topic 6, rotation of a rigid body. Thank you.